Go.
Okay. I'm Savannah Linz, and I'm going to teach you about the unit circle. Standard 5 in Yield Kisner's class. So the objective is to understand the patterns that make up the unit circle so that you can use it to your advantage. The unit circle is a circle on the xy axis with a radius of 1 and an origin of 0, 0. And it's used in trig for sine, cosine, tangent, etc., and angles and radians and stuff. And vocabulary that you're going to need for this is terminal point, and the terminal point on the unit circle is when you get a degree or a radian given to you. It's the xy coordinate that corresponds with that radian or degree. Okay. So, this here is the unit circle, and I'll go over it piece by piece. So, first thing that I'm going to go over is the degrees, which is in red in the middle of the circle. It's divided up in patterns, but you have to look for the patterns. So you have your 0, 90, 180, 270, and 360. So you have 4 sections. And then you have 45 degrees, and then you have 30s. And remember that because that'll help with the radians after that. So it's the easiest part of the circle because it's literally just find out what degree it is on the circle. We've been doing that since we were this big. The next part on the circle is the radians, and the pattern for the radians is a little harder to get. It starts at 0, and it goes pi over 6, pi over 4, pi over 3, pi over 2, and then continues the pattern. One part of the pattern that is continuous is what's in the denominator. It's 6, 4, 3, 2, and then it's the reflection 3, 4, 6. And then beneath the 180, once you hit pi, then it gets a little more challenging. But you have the denominator pattern again, 6, 4, 3, 2, and then reverse 3, 4, 6. Okay, and another thing that's really helpful for figuring out the pattern in radians is instead of the circle being pi, just 1 pi, it's actually 2 pi. So from 0 to pi is actually only 180 degrees. When you go from 180 to 360, that makes 2 pi. And that's one thing that a lot of people typically mess up on, is the fact that the circle is 2 pi and not 1. And that's where the pattern of radians kind of clicks, because from 0 to pi over 6, you have 6 of them. So you can think of it as 1/6 pi. And then this, if you add 30 degrees to that and have 60, you'll have 2/6 pi, and then 3/6, 4/6, 5/6, and then 1 pi. And the same thing goes for pi over 4. You can think of it as 1/4 pi. And so then you'll have 4 of them before you reach pi. Same for pi over 3, pi over 2, which is why it's pi over 2. It is half of 1 pi. And then beneath 180, you have to think you're going over 1 pi and you're going to 2 pi. And so you have 6 pi over 6 for the 1 pi, and you add a 6, so it becomes 7 pi over 6. And then you'll add another 6, and then another 6, and then another 6, until you get here, 2 pi. 2 pi would equal 12 pi over 6, technically. And so when you reduce that, you get 2 pi. And that's why you have 11 pi over 6 here. And the pattern is the same for all of the radians. So you have 1/4 pi, and then you have half a pi, 3/4 pi. And once you hit 1, you then go to 5/4, and then 3/2 is just reduced for 6/4, if you want to think of it that way. And then to 2 pi again. And then last but not least is the coordinate points that correspond with every radian and degree. So to remember these, it's really easy. The 4 corners of the circle, I guess, not really corners, but
Circles don't have corners.
Circles can do whatever they want.
No.
And so, since it's a circle with a radius of 1, when you hit each of the 4 sides, the circles don't have sides, when you hit these points on the circle, it's moving by 1, since the circle only has a radius of 1. So when you get to right here, you're only moving over 1 unit, and so it's 1, 0. And then, since you're only moving up 1 unit with a radius of 1, you have 0, 1 for your coordinate point. And the same goes for -1, and then 0, -1. And then you go into the coordinate points along the curve of the circle. And circles do have curves, Amanda, thank you. And how I remember it is when you look at it, and when you have a pretty unit circle in front of you, when you're looking at the x-coordinate, the radical 3/2 is bigger than 1/2, which goes right here. And since this is further this way, that's where all of the radical 3/2 goes. And then, since this is a lot closer, that's where the 1/2 goes in the x-coordinate. And then you switch the 1/2 and the radical 3/2. And then those, not really corners, but the midpoint of the curve is always radical 2/2 and then radical 2/2. And the signs on each of your points change based off of what quadrant you're in, and that's just basic algebra. The only coordinate points, the numbers that make up your coordinate points that you will ever have are 0, 1, -1, radical 3/2, 1/2, and radical 2/2. You'll only ever have those, and then positive and negatives in each. So if you get a coordinate point that has something that's not one of those numbers, then you probably have an incorrect coordinate point.
You got messed up.
What am I at?
741.
Oh, praise Jesus. Okay.
Oh.
Okay. And so, remembering what radian coordinates with what degree and what terminal point is just a matter of memorizing where 60 degrees is on the circle and 45 degrees and remembering what radian that is. It's mostly memorization. So, I have some example problems that I'm going to do. So, standard 5 is just finding the terminal points, so it's memorization and understanding the patterns of the unit circle. And so, for number 1, it gives you 5π/6 for your radian. And so if you go back here to the unit circle and you follow it to 5π/6, the terminal point of that would be negative radical 3/2, 1/2. So that would be your answer for that one. And that's what you do with radians. And the same thing is what you do with degrees. So you go to your unit circle, it gives you 300 degrees, and you follow it until you hit 300, and the terminal point for that one is 1/2 negative radical 3/2. Then some problems might be a negative number or a number that doesn't hit on the unit circle exactly. And so what you do for these is you have to add 360 until you get to a number that hits the unit circle. Because if you have a negative number, it's because you're just spinning continuously on the circle. The camera isn't pointed over here, but it can hear me, that's fine.
That's right. I'm on that job.
You. So 540 is still somewhere on the unit circle, but you have to add 360 until you get back on this particular unit circle. So 540 is somewhere, yeah, 360, you're at 360,
I got you.
Yes.
That's not.
And adding 360 once is not enough. And so you have to add it twice, which will give you what is it?
180.
180? Okay. And that is on the unit circle. Hello, Belle. That is on the unit circle. And so you follow it to 180, which is right here. And this is your coordinate point. You guys can go if you are going to be able to class.
I have PE. I don't
My
care.
Class is down.
Kisner will be a sweetheart and write you a note, right? Thanks, Teach.
My class is downstairs. So.
Anyway,
Anyways.
so fourth one, it gives you a negative radian, and this is where most people get confused. You can't add pi and you can't add 360, so you add 2 pi. And 2 pi for a radian over 4 would be 8 pi over 4. That equals 2 pi. So you add that, and you get 5 pi over 4. Easy peasy lemon squeezy. And you follow that on your unit circle right here. So you get this coordinate point. And the last one is another one with a negative degree. This one you only have to add 360 once. And you get positive 210.
Thanks,
I can do that mental math.
Don't lie.
So you follow that on your unit circle to here. And then that is your coordinate point. So all this is memorizing the patterns of the unit circle, and once you have that and you can fill it in without cheating, then you can memorize it and keep it in your head and just follow it in your head. And how much time do I have left? I mean, like, what is the time?
12:20.
I'm
It's good.
solid. Cool.